Hey everyone, and welcome. Today, we're going to pull back the curtain on a hidden aspect of the electricity you use every single day. It's all about efficiency and making sure you're actually getting what you pay for from the power grid. So, let me ask you something. Are you paying for electricity you're not even using? I know. It sounds kind of crazy, right? But for a lot of places, especially big businesses, the answer is, weirdly enough, yes. A chunk of the electricity that's flowing through the wires isn't doing any useful work at all, but it's still costing money and putting a strain on the entire system. So, how are we going to tackle this? First up, we'll look at the real cost of power. Then, we're going to decode something called the power triangle. After that, we'll figure out why power goes to waste, check out the super clever solution, and wrap it all up with the awesome benefits of getting efficient.
Visit youtube.com/avidsystem and don't forget to subscribe.
Okay, let's dive into our first section, the real cost of power. Think of this as the unseen waste in your electrical system. It's kind of like having a leaky pipe in your walls. You don't see the water, but you're still paying for it. Except here, we're talking about electricity. So here's the fundamental thing you gotta get. In any AC circuit, which is basically everything you plug into a wall, there's the power that actually does the work, and then, well, there's the power that just doesn't. And this quote really nails it. Wattless power. What does that even mean? Well, imagine a bunch of energy that's just sloshing back and forth in the wires. It's not lighting a bulb, it's not spinning a fan, it's doing nothing useful. But it's still there, clogging up the system like traffic on a highway. Okay, to really wrap our heads around this, we need a picture. And that brings us to our next section, decoding the power triangle. This is, hands down, the best way to visualize these three different faces of AC power. All right, first up in our triangle, we have true power. This is the hero of our story. It's the good stuff, right? The power that's actually getting the job done, making light, creating motion, all that useful work. We measure this in watts, which you've probably seen on your light bulbs. Next, we've got reactive power. You can think of this as the lazy sidekick. It's the power that things with motors, like your AC unit or a factory machine, need just to build up a magnetic field to get running. But here's the catch. It does absolutely no useful work. It's just there, kind of hanging out. And that brings us to apparent power. This is the big one. It's the whole shebang. It's the true power plus the reactive power. It's the total amount of power the utility company has to generate and push down the lines to your building. It's what the grid sees. And when you put all three of these together, they form this perfect little relationship we call the power triangle. You've got true power on the bottom, reactive power going up the side, and apparent power as the long diagonal line connecting them. Seriously, keep this image in your head. It's super important. So, we've got this lazy power gumming up the works. But why? What's actually causing all this power to go to waste? Let's get into it and find the culprit. And that culprit has a name: power factor. The easiest way to think about it is like an efficiency score for your electricity. It's a ratio of the useful power to the total power you're drawing. The perfect score? A 1.0. That means 100% efficiency. Anything less than that, well, that means you're wasting power. So what's dragging that score down? It's these things right here. They're called inductive loads. We're talking about anything with a big motor, transformers, industrial furnaces, even some types of lighting. They are everywhere, from giant factories to your own home, and they're all creating this reactive power problem. This chart really shows you what's at stake. See that first bar? That's the true power, the amount of electricity you actually need to do work. But look at the second bar. That's the apparent power, the much larger amount the utility has to supply because your system is inefficient. And that gap between them, the third bar, that's the reactive power. That's pure waste. Okay, enough doom and gloom about the problem. The good news is there is an absolutely brilliant and pretty simple solution. So how do we fight back against all this waste? The answer is something called power factor correction, or PFC for short. And its main weapon in this fight is a simple little device called a capacitor. And just look at the difference it makes. It's a total night and day situation. Before PFC, you've got high apparent power, you're drawing way too much current, you're wasting energy, and your utility bills are probably through the roof. But after PFC, everything gets better. You draw less power, waste is practically eliminated, and those bills start to shrink. It's a huge win. So, how does this magic actually work? It's really just a three-step process. First, an expert analyzes your system to find the machines that are causing the problem. Second, they install these capacitors right next to those machines. And third, this is the cool part, the capacitor provides that lazy reactive power locally. This means the power company doesn't have to send it all the way from the power plant. It cancels out the waste right at the source. So smart.
All right, we've got the problem and we've got the solution. So let's zoom out for a second and talk about the final piece of the puzzle, the benefits. Why does having a better power factor matter so much?
The benefits are massive. Of course, you get lower electricity bills, that's the big one, but it also means less energy is lost as heat in your own wires. It actually increases the capacity of your existing electrical system, so you can add more machines without a costly upgrade. You get better, more stable voltage, and big picture, it helps create a more stable and efficient power grid for literally everyone. It's a ripple effect of good. And this is the ultimate goal, 1.0. A power factor of 1.0 is also called unity. It's the holy grail. It means every single drop of power being supplied is doing useful, productive work. Zero waste. And that really leaves us with a final question to chew on. If we can make our electrical systems this much smarter just by tackling this one invisible problem, what's next for energy efficiency? What other hidden waste is out there just waiting for a clever solution? Thanks for joining me on this deep dive.
Thanks for watching.